we're just making comparisons here. So you do have to think abstractly, but I think you can do it. So, Jen, you're next in line. The first one is compare theta 1 with theta 2. Is theta 1 greater than theta 2? What do you think? Jen, what do you think?
Okay. Yeah.
Yes. It's obviously larger than theta 2. Okay. T. It's true. Brett, is x2 larger than x1?
Yes.
Yes, it's obvious. I don't think we really need to say anything more than that. Okay, this base x2 is greater than this base x1. Nikki S., is y1 greater than y2?
True.
Yes. This height is greater than this height. Chowan, is r less than y1? False. R is the radius or the hypotenuse of these right triangles. Hypotenuses are always the largest or longest side. Next, Val. The sine of theta 1, do you think that is less than the sine of theta 2? I agree with you. Okay. You need to know that sine is opposite over hypotenuse. And in this triangle, the tall triangle, the ratio of opposite to hypotenuse will be greater than the ratio of opposite to hypotenuse in the second triangle, or in the shorter triangle. If you don't understand these things, there's nothing wrong with you. One thing I suggest is plugging in numbers for y1 and y2. Just know that the y1 number has to be bigger than the y2 number, obviously, because y1 is larger than y2. If you have a question, just ask. Next, Dominique, is sine of theta 1 less than the cosine of theta 1? False. Again, you need to know that sine is opposite over hypotenuse and that cosine is adjacent over hypotenuse. Because the opposite side is larger than the adjacent side, that means that sine will be greater than cosine. Remember, these names just stand for pretty basic things, just ratios of sides. We've just given them special names, that's all, because we use them a lot. Good. Terry, let's compare tangent and cotangent for theta 1. Do you think tan is greater than cotan there? Oh, yeah, I agree. Because the opposite side is greater than the adjacent side, that fraction is going to be greater than the reciprocal of it. Again, if you don't get it, just plug in numbers and prove it to yourself. That can always be done.
I have a question.
Yes?
How do you know if the number is like work?
One has to be larger than the other. So in this case, do you see how y1 is bigger than x1 for the tall triangle? Yeah. So that just means that the number you give for y1 has to be bigger than the number for x1. So I'll just make y1 5 and x1 4 or 2 maybe. Then when you do something like tangent, it's opposite over adjacent.
You have to plug in something to R.
Not for tangent or cotangent, but for sine, cosine, secant, cosecant, yeah. And what I would do then is, instead of just doing a random number, use Pythagorean theorem. So it'll be the square root of 2 squared plus 5 squared in my case, so 5.4.
Wait, isn't Pythagorean theorem only for right triangles?
It's only for right triangles, yes. And that's what we have here.
That's right.
Yeah. These are both right triangles. So anyway, just to finish up, if we find cotan, that's adjacent over opposite. So you can see 5/2, which is 2.5, is greater than 2/5, which is 0.4. Thank you for asking the question. Next, Nick. True. So now we're focusing on theta 2. We want the ratio of hypotenuse to opposite. That's cosecant. And we want to compare that with the ratio of hypotenuse to adjacent. So I'll just write that here. Because the hypotenuse is the same in both cases, you can ignore it or just think it's 1. That will make the thought process easier, I think. So Nick, in the theta 2 triangle, which one is larger, y2 or x2? x2 is larger, and x2 is the adjacent. Okay, so what you have is 1 over a larger number, and then here it's 1 over a smaller number. Okay, and then Nick, which one of these fractions is going to be bigger? 1 over a smaller or 1 over a larger? 1 over a smaller. If you don't get that, plug in numbers. If you have 1 over 2 versus 1 over 3, 1 over 2 is greater than 1 over 3. The larger the denominator, the smaller the number overall. Okay. So this will be larger. And that refers to cosecant. Cosecant is larger than secant. So false. False, right? Let's go over it again. I've made many errors in my life. Cosecant, hypotenuse over opposite. Secant, hypotenuse over adjacent. Okay, I'm going over it again for my own purposes then. Because the opposite is smaller than the adjacent, then I expect that this fraction will be larger. Okay, it's like how 1 over 2 is larger than 1 over 3. So I expect cosecant to be larger than secant, not smaller than it. So I stand by false. Okay. If you're thinking hard, that's normal. Next up, Jessica. True? I agree. So the theta 2 triangle has the longer base, and cosine is the base over the hypotenuse. So this one is going to have a larger cosine than this one. And then Gabe.
False.
False. So what you were saying is that the ratio of hypotenuse to adjacent
R over x2
is greater than
yeah, y2 over x2.
y2 over x2. Like in a previous one, because you have this constancy here, you can ignore it. And then ask yourself, is r greater than y2? It's got to be, because it's a hypotenuse.
Yeah.
So this is a true statement that secant will be greater. But when you look at this statement, it says that it's less. Remember, a big part of math is just thinking, learning how to think, thinking deliberately and clearly. Nikia, do you think that the tangent ratio for theta 2 will be less than the tangent ratio for theta 1? I agree with you. Opposite over adjacent here is going to be smaller than opposite over adjacent here, because opposite is smaller here. That's it. Good enough reasoning. And Sue, do you think the tangent of theta 2 will be less than 1? I agree with you. Tangent will be 1 when the opposite is equal to the adjacent. And here, the opposite is less than the adjacent, so you're going to have something that's less than 1. For example, like 2 to 3 is a number that's less than 1. And Nikki B, last one. Cosecant of theta 1, so r over y1. Do you think that is greater than x1 over y1?
Yeah.
Yeah. R is the longest side over a side that's smaller than it, so that's going to be a number that's greater than 1. Comparing that to this, which is a number that's smaller than this, so that's going to be a number that's less than 1. So this is true. Okay? Mental workout. Math is like mental gymnasium. Any questions on that?